10th Physical Science Lesson Classification of Elements, the Periodic Table. Topic Modern Periodic Table. There is a difference between the Mendeleev periodic table and the modern periodic table. Mendeleev periodic table depends upon the atomic weight, but here modern periodic table depends on the atomic number. First, the modern periodic table made by Moseley scientist. Moseley scientists sent high energy electrons into elements, then observed the number of positive charges formed in atom of elements. Positive charge means protons. This proton number is called atomic number. So here is a diagram. These are high energy electrons. So when Moseley sent these high electrons on through elements, then these elements emitted X-ray. So when X-rays are emitted from the elements, the lines of charges formed on the slides. So Moseley called these lines of charges protons. So different elements used here, different kinds of lines formed on the slides. So Moseley named these lines of charges protons. So according to the protons, the modern periodic law may be stated as the properties of the elements are periodic functions of their atomic number. When we measure the atomic number as a protons, then the modern periodic law may be stated as the properties of the elements are periodic functions of their atomic number. But here, when we observe atom, so where do you find the protons? In the nucleus. Protons and neutrons are there. And there is no reaction of protons. And the electrons are revolved around the nucleus. So there are number of orbits are there around nucleus. So in these orbits, the electrons are rotated, and the electrons are arranged in the orbitals of subshell present in the main shell. Subshell S, S, P, S, SP, D, F, like that. So all the electrons are arranged in the orbitals of subshells present in the main shell 1, 2, 3, 4. So the physical and chemical properties of atoms of the elements depend not on the number of protons but also on the number of electrons and their arrangements of electron configuration in atom. So the electrons are arranged in the orbitals. So it is the properties, physical and chemical properties depends on the arrangement of electron configuration. So the physical and chemical properties of elements are the periodic function of the electronic configuration of the atom. So physical properties and Chemical properties are the periodic functions of the electronic configuration of their atom. So, according to modern periodic law, we confirm that properties of elements are periodic function of the electronic configuration of their atom. After knowing the atomic numbers of elements, it is easy to eliminate the problem of anomalous series mentioned in the Mendeleev periodic table. Tellurium atomic weight is more than iodine, but atomic number of tellurium is less than iodine. So kept tellurium before iodine in the modern periodic table. So it is a modern periodic table. So this is tellurium iodine. So tellurium is placed before iodine. Tellurium atomic weight is more than iodine, but tellurium atomic number is less than iodine. So according to the atomic number, the tellurium is placed before iodine. Okay. Next, when we observe this modern periodic table, so vertical lines drawn here and vertical lines drawn here. So 1 to 18 groups are formed here, and 1 to 7 periods are seen here. And here S block elements, P block elements, D block elements and F block elements are there. Totally 108 elements are there. Okay. So why these two groups elements are called S block elements, next P block elements, next D block elements, next F block elements? In previous class already we learned about the arrangement of the electrons. So the last electron or valency electron or differentiate electron when enters into the S subshell, so then the elements are called S block elements. When the last electron enters into the P subshell, so then the elements are called P block elements. Next, when the last or valency electron goes into the d orbital, then the elements are called D block elements. When the last or valency electron goes into the F subshell, so then the elements are called F block elements. Okay. Next one here, when we see this modern periodic table, Roman numbers are eliminated here. Only Arabic numbers are seen here, 1 to 18. Okay. Next one, position of elements in the modern periodic table. Position of the elements. So 118 elements are there. So which element kept in the first group and second group, like that in is totally 18 groups are there. So these 18 groups are filled with elements. Okay. First one, we can see here first one. The modern period table has a 18 groups and 7 periods. So from these 18 groups are there and 7 periods are there. 1, 2, 3, 4, 5, 6, 7. Only 7 periods are there. Okay. First group electron configuration NS1. So this is a first group. First group electron configuration NS1. NS1. N means principal quantum number. Principal quantum number 1. N means. S means subshell. 1 means electron. Okay. So the last electron enters into the S subshell. Okay. So here hydrogen. In the hydrogen only one electron is there. So it goes into the S subshell. So here first orbits. Only one electron is there. So it enters into the S subshell. Okay. So the electron configuration is 1s1. And lithium. How many electrons are there? 3 electrons are there. Electron configuration 1s2, 2s1. So the last electron goes into the S subshell. Sodium. 11 electrons are there. 1s2, 2s2, 2p6, 3s1. So the last electrons enters into the S subshell. But here we can see last electron only one is there. In the S orbitals, one orbital is there. So the first group electron configuration is NS1. So in the first group, the elements which configuration is a electron configuration is the NS1. So all these elements kept in the first group. Why? Because last electron shows NS1. Here we see hydrogen 1s1, lithium last 2s1, sodium 3s1, like that. So last S1 is there. Only one electron is there. Valence electrons only one is there. So these elements are kept in first group. Okay. And second group electron configuration NS2. N means principal quantum number. It shows number of main cells present in atom, and S means subshell. It accommodates 2 electrons. So second group beryllium, 4 electrons are there. Electron configuration 1s2, 2s2. Magnesium 12 electrons are there. 1s2, 2s2, 2p6, 3s2. Calcium 20 electrons are there. 1s2, 2s2, 2p6, 3s2. So last 2 electrons accommodated in S subshell. 2 beryllium last 2 valence electrons. Magnesium last 2 valence electrons. Calcium valence electrons also 4s2. So the electron configuration of second group is NS2. So all these elements placed in the second group NS2. So both these first and second groups are called S block elements. Okay. In the first group elements, last electron enters into S subshell showing electron configuration is ns1. In second group elements, last electron goes into subcell as a electron configuration ns2. So they are called S black elements. So first black ns1, second black ns2. So both of them are called S black elements. And first group elements also called alkali metals. Alkali metals means they first group elements comes from the plant ashes. So they are called alkali metals, and second group elements are called alkali earth metals. So these also appeared as a ash but obtained from the earth. So these are called alkali earth metals. Okay, so first group elements and second group elements. First group elements electron configuration ns1, and second group elements are electronic configuration ns2. So both of them are called S black elements. Okay, so all these about the S block elements. Okay, thank you.